All right, let's move further into our Colab notebook here for the course and look at self-attention and dive into how that actually works. So like I said, we're using the BERT model in our hands-on activities here simply because there's a really cool visualization tool called BERTViz that we can use to see what's actually happening at the various attention layers. So we're just going to import what we need here. Again, this is coming from Hugging Face, both the BERT model and BERT tokenizer that works with BERTViz, and also the show function, so we can actually show graphically and interactively what's actually going on with self-attention here. So the first thing we do is create a tokenizer visualization, pre-trained from model name, which we defined earlier to be BERT whatever it was. So if we scroll back up, that's BERT base uncased. All right. So remember, you do have to run these in sequence. So if you didn't already, if you're not in the middle of running this notebook, you need to go back and start running it again within this kernel, right? Because otherwise that won't be defined. But once we have that pre-trained tokenizer, we're also going to load up the pre-trained model. And again, this is just the magic of Hugging Face. We can, with one line of code, load up a pre-trained BERT model that we can just use and make predictions from and generate text from. Then we call the show function to visualize what's really going on in the attention layer for a given string. So let's go ahead and kick that off. And you should see something like this. Right now, it's going and downloading those pre-trained weights and biases and all the other parameters in BERT. Pretty impressive that we can just do this for free. That shouldn't take too long, actually, which also is impressive. And now we can visualize what the phrase "I read a good novel" looks like to the attention layer. All right, so you can see you can select any layer and any head. We're doing multi-headed attention here. So by selecting the topmost head that I have, I can kind of see what's going on. So to go back to the slides, remember we had two different examples. One was the sentence, "I read a good novel," where novel means a book. And then we had the sentence, "Attention is a novel idea," where novel means something else entirely. So self-attention is how we determine the meaning of a token given its context. And that's an important thing. That's the whole trick here. So if I hover over novel, I can see that it has a pretty strong connection to the word read. And it's going to use that connection to figure out, hey, by novel, I mean a book, because we're talking about novel in the context of reading something. All right. Let's do the same thing with attention is a novel idea. So again, I'm going to look at the topmost head, layer 0. This shouldn't take too long. And now if I click on novel, you can see that that's been tied most strongly to the token idea. So given that novel is being used in the context of idea and not reading something, self-attention can figure out that I want to encode this token into another token when I'm done with this layer that really captures the meaning of an original idea, something new, right? So the whole thing with self-attention is basically another layer at the bottom of each block of our transformer, right? So beneath each decoder, there's a self-attention layer. That self-attention layer's job is just to translate these raw tokens into tokens that carry more meaning as to what these tokens really mean in context. All right, that's the magic of self-attention. Also, I want to call your attention to this link from Hugging Face itself. They have another cool visualization tool of their own that just runs on the web. Don't even need a notebook for it. So yeah, I want to continue. It's called exBERT. Again, it's built on BERT, but it doesn't matter because self-attention is the same, more or less, across all these different models. And now we can type in again, for example, I read a good novel. It would help if I spelled it right. And hit update. And now if I go to the topmost layer here, and we click on novel, we can see that again we have that connection to the word read. It's extracting some context from. And even more interesting, it says would predict here. So what's it really gonna represent that as when we get through self-attention? Well, it turns out that the next best thing after the word novel is the word book. So it has in fact figured out that by novel, I mean a book. That's cool. Let's try the other sentence. Attention is a novel idea. And now if we click over, let's select the top layer still. And now when we click on novel, we can see that the top prediction below novel is the word new. So pretty cool. It worked. So it was able to figure out based on the context that this is not a book. This is something new. And this is just a way to play around and sort of explore how self-attention works. Also of interest, the word attention here got broken up into 3 different tokens. So at-ten-chun. Sometimes it does that. So kind of interesting. There's also this visualization here of all the different heads and what they're doing, but we don't really need to go into that much depth. Back to our notebook. So yeah, that's self-attention in action. And if you want to play around with different sentences here and kind of experiment, either within your notebook or at exBERT, feel free. The more you mess around with it, the better of a feel you'll get for it. Also, if you were to click on one of these words, so let's say I went to novel here and hit that plus button, you can actually visualize the query, the key, the value, the dot product, and the softmax. So this is basically the entire self-attention layer here, and you can see what's going on as you go through it. Kind of hard to interpret what this means, but it just reinforces what we showed in the slides about the mechanism of how self-attention actually works. And here you can see, yeah, it's working as I described it. All right, and again, that's the whole key to how these large language models work. Well, it's more to it than that. Embedding is important too, and the depth of the neural networks inside of it certainly, and the training material. But this was really the key insight that turned the whole industry on its head. When that Attention is All You Need paper came out in 2017, that's what kicked off this whole new era of artificial intelligence. And this is the heart of what's going on there.